Hey everybody, welcome back to my video series on building the Bearhawk 5. If this is your first time watching one of my videos, welcome. If you suffered through one of the other couple of videos I made and you decided to watch again, well, thank you. From this point on, I'm going to start transitioning from why the Bearhawk, showing you how I set up my garage, to showing you how I built my rotisserie for the aircraft. Now, I went back and forth for quite a long time figuring out whether I even wanted to build a rotisserie. There's a lot of fantastic examples online out there. I know Nev in New Zealand, he had a really unique creation with his Bearhawk 4 that he built. And instead of using a rotisserie, he had a wooden frame that he mounted to the firewall that he was able to turn and manipulate the fuselage in the garage, which seemed really simple, really easy. I know Colby has his own wooden framed rotisserie with, I think there's a metal spine down the middle, so he built that one out of wood as well. I scoured the internet, and from what I found, the easiest thing for me to do was to use the Harbor Freight engine stands, 2 of them, and connect them with a spine down the center. I'm trying my hardest to make this as simple and easy as possible. I wasn't sure I was even going to do a rotisserie, and the feedback I got from the community was, don't complicate it, just make it as simple as possible. So in that spirit, I found a pretty unique way, I guess, to make a really easy, cheap rotisserie that I hope is going to work just fine. The whole thing took me about probably 8 hours to build. I had most of the parts around my house. What I didn't have, I used Facebook Marketplace to find used engine stands that are really affordable. So let me go ahead and show you what I did. Stay tuned. All right, guys. First question that comes to mind. Am I insane to trust the Harbor Freight engine stand to support my fancy new airplane kit that's coming? It took me a long time to answer this question online because, quite honestly, I wasn't a believer that I should be doing this, but it seems like there's enough builders out there in the community that have successfully used the Harbor Freight engine stands to build their aircraft without really any issues whatsoever. I must have seen up to 100 videos online on how to build a rotisserie using just the Harbor Freight engine stand. So that gave me the confidence that I needed to continue this project. What I did was, instead of going and welding anything, I trying to stay true to my mission of making this as simple and easy as possible to give me the time to move on to other projects in preparation of the kit coming. So I simply used 3/8" hardware bolts with lock washers and lock nuts to connect the 2-inch steel tubing along the spine of the front and the back engine stands. The Harbor Freight engine stands have holes drilled actually in the middle of the aft cross member and the front cross member. So I just used the existing holes and I drilled holes inside the 2-inch tubing to connect them with bolts. It was pretty simple. And I'll turn it over to show you guys. It really didn't take much effort here. This took me all of about 15 minutes. Probably took me longer to drill the holes than anything. And I feel like it's going to be plenty strong to support the aircraft fuselage. The other issue that I had was I wanted to be able to move the fuselage around my garage. I know that some people will put furniture dollies under the fuselage to assist moving it. Some people will just put regular dollies. Actually, they'll lift one of the front sides up and maybe the back side and have 3 or 4 people help them move it around the garage. But an easier solution was just to connect the spine to the front to the back, which will add lateral stability through the rotisserie and allow me to move the fuselage once it's hanging on the rotisserie. So that's what I did. Staying true to making it quick and easy, I went to Amazon and bought these. I think they're 1/4" or 1/8". No, I think they're 1/4" steel plates. They already had holes drilled into them, so I simply just match drilled the holes on here with the holes that already existed in my 2-inch tubing and connected them with, once again, the 3/8" steel bolts. And let me show you how it looks. All right, so here's how the rotisserie looks after I connected the spine. And you can see it's just, once again, it's all connected with just 3/8 inch bolts and flat iron I got on Amazon. Okay, here we have it. Both stands are cut in half. It's not the prettiest cuts in the world using the cutoff wheel, but it really doesn't matter. Like I said, at the end of this, it's probably going to end up in the scrap pile anyway. So we have the engine stand here. What I'm going to do next is get this 2-inch pipe, 2-inch tubing, insert it in. Figure out the spacing that I need. I believe 46, 48 inches from the center of rotation. Drill some holes, drill some holes between the stand and the tube. Secure them with 3/8 inch bolts. And then on to the next step. Stay tuned. All right, guys, I feel like this is a good time to interrupt the video and show you where we're at. So, as you just saw, I chopped the vertical stands in half with the cutoff wheel. I needed 46 inches from the center of rotation to the floor, so I had to take 10 inches off of this 2-inch tubing. And then I drilled out 4 holes for the 3/8 inch bolts that are going to support the extension here. I left inside of here about 4 inches on each side of extra steel in case I needed to change the height. But looking good so far. I'm going to do the same thing to the other side. Where we are is I went ahead and welded the 2-inch tubing, an automotive U-joint from Amazon. I think this is actually for a steering column, onto the 2-inch tubing. The reason I did this was because you need to be able to rotate the fuselage, the aft and the forward fuselage, freely without any sort of binding whatsoever. And some people can do it just by simply having a flat plate on the front and a flat plate on the back. The measurements have to be pretty much precise for that to work. Otherwise, if the front fuselage is maybe a 1/2 inch or 2 inches higher than the back side of the fuselage, and you try to twist it, it's going to bind. It's going to potentially put stress on the fuselage, something I just didn't want to deal with. So it wasn't that big of a deal to just weld this. I know at the beginning of the video I said I was going to try to avoid welding, but in this situation for this steel frame fuselage, I really couldn't find a better way to go about doing it. So what we did is weld it on to the tubing so that as it spins, it doesn't just spin, but it'll spin and it'll articulate. So there'll be no binding issues whatsoever. So if you envision the fuselage mounted vertically here, as I spin the back, even if the back is slightly off, or maybe not entirely plumb to the ground, it'll flex at the U-joint. And then here I just took a little bolt, put it in the top, and that'll stop the rotation when I need it to. All right, mine's not this pretty, but this is the rotisserie that they use in Oklahoma at the Bearhawk factory. You see the U-joint there around the square tubing that's mounted to the engine mounts in the forward part of the fuselage. All right, it's pretty similar in the aft section of the fuselage. You see there's just another U-joint going into some pipe that fits into the tail wheel assembly. So pretty simple in the back, and that's what I'm hoping to do as well. I thought I'd finish up just by talking a little bit about how I think it went. And overall, I think it went pretty good. I really tried to use everything that I had around the house just to keep the project as cost effective as possible. These airplanes are really expensive, as I'm sure all of you know. So anytime you can save a buck, it's probably a pretty good idea. Would I do it again? I think I would, yeah. I mean, overall, I have, I think, 8 hours of time into the build, probably over 3 weeks because I've been doing it really slowly. And maybe $250, $225, something like that. I mean, buying one of these things new, they're a couple $1,000s. So, if you have a few extra hours and a little bit of time, it's really the way to go. It's going to save a lot of money in the long run. And it was just a fun project to do. So I definitely would do it again. If there's something I'd do differently, I probably would have figured out the issue with the U-joints earlier on in the project. I didn't really have the foresight to think ahead all that well. I thought I was going to be able to just probably work by just plumbing the mounting brackets and the plates straight to the ground and get away without using the U-joints, but I think that would have been a horrible idea. So I'm glad I did it, and I wish I would have thought about it earlier in the process so I could have saved myself a little bit of headache. All right, guys, that's it for this video. Thanks for watching. Next week is going to be the start of production. So the kit comes, and we're going to go right into building the kit. So the next video I think is going to be just unpacking the kit, inventory, just showing everybody what comes with the kit, and going on from there. Appreciate everybody watching, and stay tuned, come back, watch again if you're interested. Thanks again.